Hello, sixth graders. I am going to just create a short video to go over finding area of 2D shapes when I was grading your quiz last night, and I know only about half of you have taken it, but the scores were not okay. So most of you need to go back in and redo that quiz. So we're going to just go over how to find 2D shapes. We're going to also take a look at the quiz questions themselves a little bit. So first of all, we want to talk about rectangles, which I don't have on the screen, except just over here. A rectangle we know is just length times width. I just think of a parallelogram as just a slanty rectangle, except now we're giving it new names. So instead of length times width, we're calling it base and height. And base and height have to be perpendicular to each other. So perpendicular is when you have these right angles, 90-degree angles right here. So when I look at this shape, I'm looking for the two parts that are perpendicular to each other. So that's this line, sorry, it's a little slumpy, and this line. I am going to ignore the measurement on the slanty lines. So I'm just looking for base times height. So here, base times height. So it's the 6 and the 15, the two that are perpendicular. I'm going to ignore this one. Base times height. So again, the two that are perpendicular. So the 17 and the 13. I'm ignoring the one that's on the slanty side. Sometimes parallelograms might look like this. So you need to look for the two that are perpendicular. So here we have the 10 and the 12. So this one is on this one is not perpendicular to the other two. Base and height are perpendicular. Sometimes the height line might be drawn outside the parallelogram. See, it's kind of hard to draw a height line. Oh, geez, that's super not straight. It's kind of hard to draw a height line inside of that shape. So sometimes it's drawn outside the shape. Okay, so this one. This time, we do not need this 6, but we do need, this is the base, and the height is way over here. Okay, so you need to pay attention to the two lines that are perpendicular to each other. Sometimes it might be labeled on the top side of the parallelogram. Again, not the slanted side. Okay, so that is area of parallelograms. So triangles. Triangles are half of a square or a parallelogram. Triangles and trapezoids, the two that start with TR, we are going to divide by 2. So what you're going to do is find the length and the width, or the base and the height, and you're going to do half of it. So again, this is the exact same with the parallelograms. Base and height are perpendicular to each other. So we have the 13, sorry, my pen has disappeared. We have the 13 and the 12. Now, in a right triangle, this time we're going to look at the 10 right here and the 18 right here. Okay, we're not looking at the slanted side. The 10 and the 18 are perpendicular to each other. So base times height divided by 2. So if you look at this, 18 times 10, base times height divided by 2. 1/2, remember, means the same thing as divide by 2. So 1/2 of 18 times 10, which is 90. Area is always squared. Okay, so sometimes the height line is drawn inside. So here I would go 28 times 10 divided by 2. Right triangles have this 90-degree angle right here. So a right triangle, the height line is going to be one of the sides, the 8 times the 6, but not the 12. I don't need the 12. So 8 times 6, which is 48, divided in half, which would be 24. Okay, look at this one that's sort of sideways. This time, again, I'm looking for the perpendicular side. So 9 and 20. I'm going to ignore the 13s. So 9 times 20, and then do it in half. So 20 times 9, 2 times 9 is 18, 180. Then half of that is 90. So sometimes it's inside. Here's one that's kind of slanty. Again, look for the two that are perpendicular to each other, and then you need to divide in half. Okay, this one's upside down, but this one and this one are perpendicular to each other. 12 times 18, divide it in half. Sometimes the height line might be drawn outside. So, and this is an obtuse triangle, so it's drawn outside. So 11 and 16. We don't need this little 5. I don't care about that measurement. Doesn't matter. 11 and 16. This one, look, I have to add the two parts to get the entire base. So I'm going to add the 4 and the 18, then times it by the 18, and then divide it in half. I don't care about the 20 and the 25. Okay, trapezoids. So trapezoids formula, we're not going to go into the why, though that would have been a great lesson if we'd been in school. But trapezoids, we are going to add the top and the bottom, times it by the height line, and divide it in half. Okay, so in this one, I'd add 9 plus 13, times it by 11, divide it in half. Trapezoids, triangles are both divided in half. Again, you are looking, the two bases are the two lines that are parallel. So remember, parallel means going forever and ever and not touching. So you're looking for the two sides that are parallel. So in this case, it's the 10 and the 12. 10 plus 12, 22. Here's the height line. A height will be perpendicular to the two bases. Times it by 13, divided in half. Here, 6 and 20. Those are parallel. The 10 is perpendicular, so that's the height line. So 6 plus 20, 26. Times it by 10, that would be 260. Divide it in half, and you get 130. In this one, I don't need the 15. Okay, let's see. This one, 1 plus 6, add the two bases. So that's 7, times it by the height. So 7 times 3 is 21. Half of that is 10 and a half. Okay, now this one's turned on its side, but don't let that trick you. Here is a base. Here is a base, 14 and 20. Add those together. The height line is perpendicular. Times it by the height line, divide in half.